Okay, the next section, 7.3, we're going to solve trig equations today. So we're going to learn standard algebraic techniques to solve these. We'll do some quadratic ones that require, the quadratic relationships to solve. And we'll do them with multiple answers, multiple angles. And we'll use inverse trig functions to solve some of them as well. So here's a quick intro example. Let's say we're trying to solve this equation, the sine of x equals 1/2. Well, if we were to graph the sine, like we have here, you're talking about 1/2 right here. Well, the sine equals 1/2 in an infinite number of places. It repeats. So there's going to be an infinite number of times where the sine is going to be equal to 1/2. And you can get that in your unit circle because the sine of 1/2 is the y value here. That happens at 30 degrees or pi over 6. And it also happens again over here at 5 pi over 6. But then it's going to repeat. That's just in the interval from 0 to 2 pi. Obviously, if you go around the circle again, you're going to have 2 more solutions, and then 2 more, and so on. So if we want to represent all those solutions, we'd say it like this then. It happens at 30 degrees where the sine is 1/2, plus any multiple of 2 pi, where n is just an integer. So n could be 0, n could be 1, n could be 2, and so on. If n's 0, we just get the 30 degrees. If n's 1, we get the 30 plus the 360, so we're talking about 390, and so on. And then also we have the 5 pi over 6 over here, plus any multiple of 2 pi. So let's do an example then. Let's solve this trig equation here. Now this one, we need to get sine by itself. We need to collect the terms that are the same. So let's add sine of x to both sides. That gives us 2 sine of x equals the square root of 2. Now let's divide both sides by 2. So what we're looking for is where the sine of x equals square root of 2 over 2. Now these answers, if we're going to do exact answers, which most of them we will, we're going to be looking at the unit circle, and we need to determine where the y value is equal to the square root of 2 over 2. That happens at 45 degrees. At this point right here in the unit circle, 45 degrees, we get square root of 2 over 2, comma square root of 2 over 2. So the sine is our y value. So that happens at this angle, which we're going to give radians for that, pi over 4. But it also happens again over here at 3 pi over 4. Now let me write these separate because these are the two solutions, but we want to be able to add any multiple of 2 pi. So I'm going to write plus 2 pi n to both of these because that way, as we go around the circle, we can include that point again. If we go around back to this point, that's another solution. So there's an infinite number of solutions, and this is all of the solutions. Now sometimes I'm going to say, just give me the solutions in the interval from 0 to 2 pi, in which case, then, we wouldn't need this part here. We just need these two. All right, let's do another example here. This time, let's just find the interval, the solutions in the interval from 0 to 2 pi or 0 to 360. Now, we need to solve this, but we have 2 different signs again. That's going to be an issue for us. But you might notice that we have sine squared then sine. That's a quadratic relationship. It might be easier to recognize if I replaced sine with y or a variable like w or any variable besides x really because I'm using x already. You'll notice it's a quadratic relationship. And actually it's a quadratic relationship that we hopefully can factor. And we can. I just guessed and checked a couple times and I got this as my answer. So now I'm going to replace y with sine of x again because that's what y is in this case. And I get this. So I need to solve this equation. So what I'm looking for are solutions to this part right here and this part right here. So I'm going to do the first part. I want to set 2 sine of x plus 1 equal to 0. I'm going to subtract 1 from both sides, in which case I get this. So I'm going to divide by 2, and I get sine of x equals to -1. Now we want to look at the unit circle and ask where is the sine equal to -1/2. Well, that's here and here. And we need our solutions between 0 and 2 pi. So that's 7 pi over 6 in a unit circle in radians, as well as this point over here, which is 30 degrees less than 360, 330, or 11 pi over 6 on the unit circle. So those are our two solutions between 0 and 2 pi. That takes care of this term right there, but I still have potentially 2 other solutions from this one here. So let's now solve the second one. So we're going to set this part equal to 0. Sine of x minus 1 equals 0. Add 1 to both sides, and we're looking for where the sine is equal to 1. Well, the sine's equal to 1 only in one spot, and it's right there. at pi over 2. So I can add that pi over 2 where the y value is equal to 1, and those are my solutions. All right, let's try a multiple angle example then. Let's solve this. We're going to add 1 to both sides, so we get 2 cosine of 3t equals 1. Divide both sides by 2. So we're looking for where the cosine of 3t equals 1/2. Well, let's just find solutions to this part first. So let's call this theta for now. Where is where is the cosine of theta equal to 1/2? Well, let's look at the unit circle. 1/2 is here. There's 2 solutions here and here, where the x value is equal to 1/2, and those solutions are at pi over 3 and 5 pi over 3 in the unit circle. Now these are solutions for theta, and they will repeat every 2 pi n because we weren't told that the solutions needed to be in a specific interval, so there's an infinite number of solutions. Now that's theta, but we called theta 3t. So let's replace theta with 3t, and let's find out what our solutions are for t now. So divide through by 3, and what happens is you're multiplying through by 1/3. You got to do it to both items. So the first one becomes pi over 9 plus 2/3 pi n. And then the second solution, if I divide through by 3 or multiply by 1/3, I get 5/9 pi plus 2 pi over 3n. So there's my infinite number of solutions for this trig equation. You can always try one, try when n is 1, for example. And when you plug that in, you get 3 times pi over 9 plus 2/3 pi, just to make sure this works. Now, when I distribute, I get 3 goes into this 3 times, so it's pi over 3 plus 2 pi. So now we want to take the cosine of that angle. Now, that angle, if you look at the unit circle, goes around, it's pi over 3, which is 60 degrees, then around once more, back to that spot. But the cosine is 1/2 there, so that does work, because when you multiply 1/2 by 2, you get 1, minus 1 is 0. So it does work if you go to check any one of these. All right, let's try an example using inverse functions now. Let's solve this. First, let's change this into 1 over cosine squared, because that's what secant is, minus 2 sine of x over cosine of x equals 4. Now, I tried combining these fractions. I tried clearing fractions and solving this, and it didn't work. I just paused it and tried that. And you're going to have this from time to time, and it's okay. It's okay to not have the end in sight. When I started this problem, I didn't know the best way to solve it. There's multiple ways, and sometimes you're going to have a dead-end road, and you're going to have to go back and try something different, and that's totally okay. So let's go back, and let's try something different. Let's try, on our formula sheet, the secant, our Pythagorean relations is equal to 1 plus a tangent squared. So let's try that. Now we have everything in terms of tangent. Let's see what that does. We can do a quadratic relationship again, so let's put this in standard form for a quadratic. What I'm going to do is subtract the 4 over, so it's -4, and plus 1 makes -3. Now I'm going to replace the tangent with w, just so that we can see that this is a quadratic relationship, and hopefully we can factor it. It factors into w minus 3w plus 1, which is really tangent minus 3 and tangent plus 1. Let me get the x in there. All right, so we're solving both of these then. We're solving for where this first part is equal to 0. So I'm going to write tangent of x equals 0, so that's where tangent equals 3. Now, I don't think that's happens on our unit circle anywhere. I don't think we can divide sine or by cosine and get 3 anywhere. So we're just going to have to take the inverse tangent of 3 to get our solution. Let's do that in radians on our calculator. We get about 1.25. All right, now let's solve this other part where the tangent of x equals -1. If we set that equal to 0 and do inverse tangent of -1 in our calculator, and we get about -0.79. So those are our 2 solutions for x, keep in mind, which is what we wanted. Now we didn't say its specific interval, and we know the tangent repeats every pi, so really what I should do is say 1.25 plus pi n, and then also I have this other solution which would be negative 0.79 plus pi n. Those are my two solutions for x, which actually are infinite number of solutions. All right, let's try the homework, and hopefully this will make more